Hello, everybody. In Module 3, I discussed models of agency problems. Module 3 has 6 lessons. Today, we focus on Lesson 4, career concern models. Career concern models is motivated by Farmer 1980 JPE paper. In this paper, Farmer argues that moral hazards is not an issue because the market is going to completely resolve the issue. As you may recall, moral hazard problems refers to the agent's efforts not being observable and the agents may shirk. Farmer's argument is that if the agent chooses to shirk, then their current performance will be low. And so market is going to perceive their ability to be low based on the low current performance, which would adversely affect their future compensation. Therefore, reputation can substitute for explicit contracting. And this is also called implicit contract or career concern. The bottom line from the Farmer paper is that the principal need not worry about the agent not exerting enough effort because it is in the agent's self-interest to exert high effort to preserve a good reputation. Holmstrom 1999 Review of Economic Studies formally shows that this argument is incorrect. And to follow the logic of Farmer, Holmstrom assumes away any explicit contract based on the current performance. In this case, how manager is compensated depends solely on reputation. Holmstrom calls such a reputation talent. And we're going to use a simplified version to illustrate this basic idea. Suppose the manager exerts unobservable effort A, and exerting this unobservable effort A is going to generate output Y, which depends on the effort A, depends on the manager's talent eta, and depends on some random noise epsilon, which is normally distributed with mean 0 and precision H epsilon. This eta talent is unknown both by the manager and the markets. There are two reasons for making that assumption. First, if we assume that the manager knows eta but the market does not know, it's going to generate a lot of tractability issues, in particular in the dynamic setting. The second is that it is not completely unreasonable to assume that we do not know completely about our own type or talent. We may have some idea, but we may not know perfectly. So the talent eta is perceived to be normally distributed with mean M1 and precision H1. This is also the prior distribution of eta. The manager is going to get paid as a function of the current outputs, and the manager has to subtract the cost of exerting the efforts. The payment to the manager is determined by the market, which is expected value of the manager's talent based on the current output. So this captures Farmer's notion that if the market believes you have a higher talent, you're going to get paid more. Now let's look at some benchmarks. The first is the first best benchmark, which has no moral hazard issue. So in this case, if A is observable, then the principal can penalize the agent for any efforts that the principal does not desire. And so the optimal solution would be choose the effort to maximize the expected output minus the cost of exerting effort. And so first order condition with respect to A results in the first best effort level being 1. We're going to see subsequently that the optimal effort level is smaller than 1, which means that the argument in Farmer is incorrect because reputation alone cannot bring the effort level all the way back to first best. The second interesting benchmark is the perfect information benchmark, when effort is not observable, but eta is known by the market. In this case, of course, the market is going to set the payment to the manager equals to eta, and that's going to be independent of Y. In this case, the manager is going to exert 0 effort because the benefits of exerting efforts is hopefully get a higher output, so to boost the market's perception of the manager's ability. But if the market already knows about the manager's ability, then there's no benefit of exerting effort. Because exerting effort is costly, the optimal effort level is going to be 0. Now, let's consider how to solve for the model. Because the manager's effort level is an endogenous choice. So, as we discussed in Module 1, Lesson 2, the market has to conjecture this endogenous choice. And the conjecture is denoted by A hat. The market observes Y. The market conjectures A hat. The market also wants to learn about eta to determine how much to pay for the manager. And so the market is going to subtract A hat from Y and treat that as a noisy signal of eta plus epsilon. Because eta is exogenous variable, the market is going to do Bayesian updating about eta. The market has two pieces of information about eta. One is y minus a hat, another is the prior distribution of eta. So the market's expectation of eta would be a precision weighted average of the two noisy signals. And the manager would then choose the effort to maximize the expected value of the market's perception of the manager's talent, conditioned on manager's effort minus the cost of exerting effort. We can see here, A hat is market's conjecture. Manager cannot change it. But Y would be a function of the manager's actual effort. So expectation Y conditional A would be M1 plus A. First order condition with respect to A is going to result in the optimal solution of A. Just know that A hat has to be taken as given. So this cannot be taken as derivative. And also equilibrium, the conjecture has to be consistent as the actual choice, which results in the optimal effort choice, A star. We can see here the optimal effort choice is bigger than 0, but it's smaller than 1. And the optimal effort choice increases with the precision of the output. If the output measure is more precise, then the market is going to put more weight on the output to gauge the manager's ability. And the manager has more incentive to exert higher efforts to boost the output, to increase the market's perception of the manager's ability. So reputation does play some role here, but the optimal effort level, as we mentioned, is smaller than 1. The reason is that output is not a precise measure of talent. So the market has to put some weight on prior beliefs, and that prior belief is independent of the manager's effort. So the benefit of exerting effort is not as large as in the first best case. That's why the optimal effort level is lower than the first best case. And so the moral hazard issue cannot be completely resolved by reputation. Now, let's look at the results in the dynamic setting. In the dynamic setting, we have a lot of periods. In every period, the manager is going to generate some output. Output depends on the manager's reputation or talent, the manager's efforts in that period, and some random noise in that period, with normal distribution with mean 0 and precision H epsilon. The manager is paid each period, and this payment would depend on all the past history of outputs. In our simple model, we only have one period, so the payment only depends on the output of that period. And the manager is going to choose effort to maximize discounted utility of each period. So each period, the manager is going to be paid WT and going to exert effort AT. And so the cost is 1/2 AT squared. The solution method is essentially the same because manager chooses effort endogenously. So the market has to conjecture the manager's endogenous choice for each period. And the manager has to take such conjecture as given when choosing the actual choice. In equilibrium, the actual choice has to be the same as the conjecture. However, the dynamic nature makes the Bayesian updating much more complicated. You can check the original Holmstrom paper for more details. But essentially, what Holmstrom shows is that the optimal effort level is going to approach 0 as t approaches to plus infinity. And so here is the intuition. When t increases, you're going to observe more efforts. And so in this case, you have a larger and larger sample size of the outputs, which means that you become more and more sure of the manager's ability based on past outputs. That also means that you're going to put less effort on any future incremental observations. That just means that we're coming closer to the perfect information benchmark when the market is sure of the manager's ability. So the marginal benefit for managers to exert effort in future periods are going to decrease. So the manager is going to exert less efforts. And when t approaches plus infinity, the market has a large enough sample. So the market is almost sure of the manager's ability. In that case, the manager exerts 0 effort. So what Holmstrom shows in a dynamic setting that we cannot see in a single period setting is that in a dynamic setting, reputation effect is temporary. Whatever reputation you have, eventually it dies out and it cannot resolve the moral hazard problem. So how to make reputation effect to be permanent? You need the talents or reputation to also evolve over time. The reason for reputation effect to die out in a dynamic setting in the previous slide is that the talent is fixed. So the more output you observe, the more sure you are of the talent level. Now, suppose talent also evolves over time. Then in that case, you can never be sure of the talent because each period, talent is going to change. And so this is how talent evolves over time. It's like a random walk process. The next period's talent is this period's talent plus some random noise with mean 0 and precision H delta. The Bayesian updating about the talent will be even more complicated. However, in this case, when t approaches plus infinity, the manager is going to exert some efforts. It's not going to be zero efforts because the talent is going to keep evolving. And so there will be evolving uncertainty about the talent. So the market is still going to use later period output to gauge the talent. And that brings some benefits to the manager of exerting efforts. Eventually, the manager's efforts can be shown to approach a steady state, which means that in each period, the manager's exerted effort is a constant. This would occur when the reduction of uncertainty of eta through learning more outputs exactly offsets the periodic increase in uncertainty of eta from constantly evolving through the random walk process. And this is the solution for the steady state. We're not going to talk about technically how we get to this condition. If you're interested, check the original Holmstrom paper. But again, we will have the optimal effort level is smaller than the first best. So again, reputation cannot completely resolve the moral hazard issue. But we can show that the optimal effort level is closer to the first best level. So reputation can resolve moral hazard issue better when beta is higher. Beta higher means that your discount rate is lower. So you care more about the future. So you care more about reputation. In this case, reputation works better to resolve the moral hazard issue. Or if the market relies more on future output to infer about the ability, then in this case, the manager is going to exert higher efforts to try to change the market's perception. So the optimal level of effort is closer to the first best. To conclude, while the reputation of career concerns can induce the agent to exert some efforts, because if we do not exert some efforts, then it's going to be a damage to the reputation or career concern through low current output. But the agency problem is not completely resolved. Effort level is still going to be smaller than the first best. So reputation or career concern is not a panacea. And the reason is because the markets cannot observe the efforts, so the markets has to form a conjecture. And so the markets has to put some weight on their conjecture because this conjecture is perceived by the market. So it's fixed from the agent's perspective. So the agent's marginal benefit when exerting effort is going to be smaller than the marginal benefit in the first best case. And we're going to see this is going to be a recurring theme in models when conjecture of endogenous actions is key to solving the model. So that's the end of this lesson. If you want to test your understanding of this lesson, a review quiz can be found at the link in the slides. Thank you very much.